Pick any 5 numbers from 1 to 8. I guarantee that one of them divides another. Every single time, no exceptions. So here's the proof. I want to prove that among any n plus 1 integers chosen from the set 1 to 2n, at least one divides another. Well, first of all, we can show some examples. For example, we can take a random set of consecutive integers, for example, from 3, 5, 6, 7, 8. And we get that 3 is a factor of 6, obviously. Or we can just do like change 3 to 2, 2, 5, 6, 7, 8. And then 2 is a factor of 8. So when you find a counterexample, but you can't. So every positive integer can be written uniquely as a power of 2 times an odd number. So we can write n is equal to 2 to the power of k times m, where m is an odd number. And then k is greater than or equal to 0. So then, we can call m the odd part of n. Now, the odd parts of every number in the set 1 through 2n, it must lie in 1, 3, 5, to 2n minus 1. And there are exactly n values. So then, we're choosing n plus 1 numbers, but there are only n possible odd parts. So by the pigeonhole principle, 2 of our numbers must share the exact same odd part. So if you have a equals to 2 to the power of j times b, or in this case, b is equal to 2 to the power of k times m. So here, we have j is less than k, obviously, so if a is equal to 2 to the power of j times m, then we know that b over a would equal to 2 to the power of k minus j. Which would belong to a set of integers. Which would mean that a is a factor of b. So that would mean that one always divides the other. So that's how we prove this conclusion here. And the bound n plus 1 is tight. You can always find n numbers with no divisibility. So we can write that n plus 1 to n plus 2 to 2n of the n numbers here none divides another. Add just one more number and it breaks every time. Pigeonhole principle is one of the simplest ideas in math and also one of the most powerful. If you like this kind of content, please subscribe. Thank you for watching.